I want to thank everybody for coming for this webinar. Again, this is a Rolls Battery Engineering sponsored training. Today we're going to talk about a few things. We're going to talk about specifically the third part of the charging settings, specifically AGM, GEL, and lithium batteries. All of these materials and more are available on our shared drive. This http://tiny.c/roll shared drive. This is a Google Drive that I share with everybody. This presentation will be on there. If you can't click the link, or you don't have it, or you misenter it, go ahead and send me an email at steve@surette.com, and I'll be more than happy to send you the link. Also, I can send you a link to our YouTube site that has 27, soon to be 30 videos on it for training. Here's my contact information. The 902 number is my number at the plant. The mobile number you see, the +1 206 790 5840, that is my cell phone number. And then also you can also use it for WhatsApp. And then of course my email address, steve@surette.com. Feel free to contact me if you have any questions. Just remember that I do spend a couple hundred days a year on the road. If you're trying to call and I'm somewhere like I was last week in Zimbabwe, it's very difficult to call in and call out. So I tend to use primarily email when I'm traveling to remote locations. Okay, so some housekeeping items. We try to keep these to 30 to 40 minutes. The one I did this morning didn't have many people in it, so it only lasts about 30 minutes. We'll have a Q&A session at the end. If you have questions, if you click on the questions tab of your interface, your GoToMeeting interface, and you type in the question, that way at the end I'll go ahead and run through those answers on those questions and respond to them written in writing. That way we can take care of it. Everybody's microphone's been muted so we don't get any kind of echoes. The first one of the webinars we tried to open that up and it got pretty nasty, so we'll probably keep it closed and do written questions only. If you don't have access to the chat pane, go ahead and email your questions to steve@surette.com and I'll be more than happy to take care of them. All right, so determining charging system settings, part 3. The first two parts, part 1 was we were talking about specifically about the different modes, things like bulk, refloat, what's end amps, absorption time, why is it important? We addressed all those in part 1. Part 2, we talked specifically about flooded lead acid batteries, programming voltages and settings for flooded lead acid batteries. This part we're going to talk about settings for lithium iron phosphate or lithium ferrophosphate, the settings for AGMs and gels with different types of settings, different types of controllers, solar, wind, hydro, inverter settings. And then we're going to go over the other settings that a few of the other settings that are most commonly asked of us. So this is the system we're going to talk about. We're going to talk about a 48-volt system. 830 amp hours. We're going to change this up a few times during this presentation, but the 830 amp hours is assuming 2 parallel strings of S6 460 AGM batteries. We're going to talk about a 4,080 watt solar array, just like we did in the second session, and of course the generic 4,000 watt inverter and 6,000 to 8,000 watt generator at sea level. Remember, if you have a generator at altitude, for about every 800 to 1,000 feet of altitude, you can lose between 8 and 10% of the generator, simply because you're burning fossil fuels at altitude and it's not as efficient. So keep that in mind when you're putting in systems that are up higher in the atmosphere. So charge controller settings for AGM batteries. The number one very important setting, just like you would for flooded lead acid batteries, is your bulk and absorption voltage. It's incredibly important. You have to get this right. It's incredibly important for any valve regulated product, VRLA, gels, AGMs, any type of valve regulated product. It's incredibly important to get these settings right from the get-go. If you don't, even 3, 4, 5 months at a lower setting or an incorrect setting is going to cause you problems with the systems. Just to give you an example, just this week I got an email from a customer with a bunch of S2 1275s that they had at a system. The customer set it up as AGM, which was a 50 or 58.2 charging voltage, and it's way too low. And so those batteries are just over a year old, and they're dead because the batteries haven't been properly charged. They've started the sulfate, and that sulfation process is 12, 14 months into it, and that's going to cause a problem. Definitely it will cause problems. The second most, actually, probably the most important charge setting is the absorption timer. On this particular system, with this battery bank, you've got an 830 amp hour battery bank. We've got a PV array that's capable of 83 amps actual peak on an 80 amp charge controller. So we're going to assume that we're doing that 70 amps of current. Oops, I do that every time. So we're going to assume that you're doing 70 amps of current into the batteries. Okay. Again, it's really important for you, especially for you installers, to actually check to see how much current's actually getting to the battery. Put a current meter on, measure it, and see what the current is, because that's going to enable you to make sure your absorption time calculation is correct. If your absorption time calculation is not correct and the batteries aren't seeing a full 100% charge, it may be 12, 24, 36 months before you start seeing problems with the batteries. And so it's imperative that you get the absorption voltage, bulk absorption voltage correct, and the absorption timer is correct. And so in this particular case, the absorption timer is 0.38 multiplied by 830 divided by that 70 amps. So on this particular system, your absorption time is going to be 4.5 hours. The biggest problem with that is that in most places, your bulk time is going to be between 90 and 180 minutes, maybe 1 to 2, maybe 1 to 3 hours for your absorption time or your bulk time. Bulk time's unmeasured. It depends on how much time it takes the voltage to get up to that absorption set point. Once you get to that absorption set point, you start your absorption time. And so ballpark, at best case, if your customer takes these batteries down to say 60% state of charge, you're probably looking at a 6 to 6.5 hour time for total charge. Granted, in the North America, you're going to get, in the summertime, you're going to get 8-10 hours of decent sunlight, but you're not getting full sunlight for that entire 8 to 10 hours. Your average is about 5.5, between 5 and 5.5 hours in the summertime, and in the wintertime, especially in the northern hemispheres, you could see 1 or 2, if that. And so your absorption time is going to affect that. So if you have an absorption time of over 3 hours, that typically means that only about 3 to 4 months of the year, you're actually going to have a healthy charged battery without having to run the generator. And so if you've got that long absorption time, you need to make it your customer very blatantly aware that they have to run the generator 2, 3, maybe 4 times a week to get those batteries to a full 100% state of charge. Because in the case of AGM batteries, those batteries need to see 100% state of charge once a week, no ands, if, or buts. If they're in a partial state of discharge over a long period of time, those batteries are going to start to develop problems. Float voltage. Float voltage generally for AGM batteries is 2.2 or 2.25 to 2.3 volts per cell. And so the 2.3 volts per cell is where this 55.2 volts is at. Okay, and the reason I have it set here to 55.2 is because my solar array is too small, because I'm never really going to hit that. I never really should ever hit float. So I'm running a little bit higher float voltage to make sure that if I do hit float prematurely, that the charge controller stays at a higher voltage and gets those batteries fully charged. Ideally, it would be best to increase the size of the array to shorten that absorption time. Equalization voltage. Yes, our AGM batteries can be equalized, just like any typical lead-based battery other than gels can be equalized. Equalization is not good for batteries. Equalization is a cover-up for improper charging your battery bank. If you are properly charging your battery bank and getting those batteries to a full 100% state of charge at least once a week, you should never have to equalize. Okay, the thing that determines when you equalize on a lead acid battery is specific gravities, but unfortunately AGM batteries, there's not really a way to tell. You can't crack the top open and look. And so typically one of the things when I suggest you do is when you install the system, you do a load test. And then, 6 months down the road or a year down the road, you're doing a secondary load test to see how the batteries are holding up, preferably about 6 months down the road. If you notice they're not holding as much load, you may need to equalize. And so equalized voltage can be anywhere from 58.8 all the way up to 60 volts. And so what I would do is I would start at that lower 58.8 to start with, or even say 59 volts, and equalize that. Don't immediately go to the 60 volts. Equalization time is typically half to 2/3 of the absorption time. So in this case, 2 to 3 hours for your equalization time after you've completed a full absorption timer. The next thing is NDAMP settings. I like to have my NDAMP settings on my AGM batteries a little bit lower, because they tend to be, while they charge faster, they tend to be a bit more picky when you are not properly charging them. And so what I typically will do is set my NDAMPs percentages at 1.5%. So in this particular case, 830 amp hour battery, I'm looking about 12 to 13 amps for my NDAMPs. As long as I get a full 60-minute timer. If you don't get that full 60-minute timer, you're going to have problems. Like for example, Schneider and Magnum, the way they determine NDAMPs is you program the battery bank capacity. So if you set the battery bank capacity at 830 amp hours at 16.6 amps for 1 minute, okay? So as soon as the current goes below that 16.6 amps for 1 minute, the charge controller or the inverter, if you're using the battery monitor kit, is going to default to float, and that is bad. And so on the Magnum and the Schneider equipment, we strongly suggest that you initially start this out at 600 amp hours, and then you might have to move that down based upon where the capacity readings of those batteries go. If your customer notices capacity has gone down 1, 2, 3 months down the road, and then I would set that to maybe 500 amp hours. And so what you're trying to do is prevent it from going to float too early. Going to float too early on a charge is a death knell for a solar system. That just means that the system's been improperly programmed. On the lithium iron phosphate, these are actually pretty simple because the battery management kit tracks all this stuff. And so I changed the system up a little bit. Basically it's the equivalent of what we had before with the 2 parallel strings, but only 390 amp hours of batteries. Oops, I do that every single time. I have no idea why or how. So 390 amp hours. So that would be 3 of the S48 6650 LFPs. Same solar, same inverter, same generator, everything's the same. And so what I do here is my bulk absorption voltage is simple, 54.4 volts. So I'm just going to program that for 54.4 volts. My absorption time doesn't matter. So it's basically the BMS manages it. So with ours, there's going to be a link box or a COM box. There's going to be, like, for example, let's say you have a Victron or you have an Outback or you have one of the other inverters other than Schneider, then you buy a card that plugs into the COM box, and then the remote of the Outback or the Victron or whatever plugs into that box. And then what that does is that shares BMS information with the charger. So when the batteries are charged, the system will send a signal back to the Outback to go to float. Okay. If you don't have that, level of communication, you don't want to put that card in, that's fine. Basically what you would do is you'd set, if it's a Schneider equipment, you'd set it to 2-stage charge. If it's Outback equipment, you set it to lithium batteries. A lot of the manufacturers, Morningstar, you set it to lithium batteries. And what that does is that puts the inverter into a 2-stage charge mode, which means it's either charging or it's not charging. And what happens is that allows the BMS, the battery BMS in the box, to manage that. Equalization voltage, it is not needed. You don't need to equalize lithium batteries. Prefer that you don't equalize lithium batteries. All that is managed, as well as NDAMPs. That is managed by the BMS. And then, of course, your battery capacity because everything communicates and everything manages, and the BMS is overriding the products as long as it's communicated, you would set your battery capacity at that 390 amp hours. The only reason I could think that you might want to go lower is if for some reason you don't tie to the communication of the products. Let's say you're using it with the Magnum and we don't have the communication protocols done or finished yet, then you might have to set it about 250 to 300 amp hours just to make sure that the Magnum inverter doesn't shut off before it should. On the gel batteries for the charge controller settings, we've got a little bit different of a setup here. 48 volt system is the same. The battery capacity is a little bit larger. So the closest match I could find it was a 1,000 amp hour battery. And so that's going to make, because our PV array hasn't changed, that's going to make our absorption times even longer, which is a mistake. This is a system I would definitely advise not installing without adding at least another 2 to 3 kilowatt of solar, because you're going to have all kinds of problems. Bulk absorption voltage. Notice the bulk and absorption voltage. It is not at 58 volts. It is not at 60 volts. It's at 57.12. On gel batteries, it's absolutely imperative that you get this setting correct. If you don't, if you set it at 58.8 or you set it at 60 volts, or even if you set it to 58 volts, what's going to happen to those batteries is over the first year or two, you're going to be basically overheating that battery. It's going to be overcharging the battery, and eventually that case is going to split, or the valve is going to stick open, and then it's going to dry out, and the battery is going to suffer a catastrophic failure. You do not want that. It is absolutely imperative that when you're using a gel battery that you have that corrected setting. Absorption timer, again, 0.38 multiplied by the C20 rate of the battery divided by the nominal charge current. That is 5.7 hours. Again, if you have an absorption timer of 5.7 hours, you're never going to get those batteries to a full state of charge with solar only. That means you need to upgrade the size of that. Oh, I'm sorry. That means you need to upgrade the size of your array. 1,000 amp hour battery bank, I'm going to want 120 to 150 amps of charge current. At that, you're looking about a 6 to 8 kilowatt solar array minimum. And if you can get it to there, if you can do that, those batteries are going to, even if your customer takes them down to 60% state of charge, you get a good Sunday the next day or 2 good Sundays with minimal loads, you're going to get a full 100% charge on those batteries with that 6 to 8 kilowatt PV array, and they're not going to suffer. Flow voltage. Flow voltage in those batteries is 54.72. 54.6, 54.7 is where I would set that. Again, in most off-grid systems, you're not going to really, you're not ever going to get the float with the solar controller, because you're not going to get 5.7 hours of absorption time unless the system's on a tracker. It's just not going to happen. So just set the flow voltage where it's supposed to be and you'll be fine. You don't want to mess with it on the gel batteries. Another one, equalization voltage. Equalization voltage is another huge hot topic with gel batteries. You do not equalize gel batteries. If you do equalize gel batteries, you're going to overheat them and you're going to cause permanent damage. Equalization voltage, I would set your equalization voltage at 57.1, maybe even drop it down to 57 volts or even 56.8. I would have it under your target absorption voltage. That way, in case someone does accidentally activate an equalization, that you're not killing your batteries because of that equalization. End amps. End amps is the same for AGM batteries. On this particular system, what I would do is end amps 1.5% for 60 minutes. That 1.5% for 60 minutes. So if it's 1,046 amp hours, I'm going to be looking right around 12. I'm going to be looking at right around 12 to 15 amps for my end amps. Again, same thing. You need to have the timer. If you don't have the ability to set the timer, then you set that end amps lower, 6 to 8, or you set it to 0, and that disables the end amps. Okay. If you have to have that timer. If you don't have a timer that counts down how long it spends at that low current, you're never going to get the correct shutoff point. And then again, just like the Schneider and Magnum, the same thing that we've talked about, and I'm not trying to beat up on them, but battery capacity, if you have that 60-minute timer, you can set it for 1046. But if it's a Magnum or Schneider product, you're looking at 800 amp hours. Realistically, it's going to be about 700 to 800 amp hours. Again, the only way to test these batteries, these gel batteries, is to do a load test. You can't take the tops off to look at specific gravities. So you're definitely going to have to work with your clients on the end to make sure that they get that these settings are correct across the board. Inverter charger settings for the lithium. Again, same thing as before. Float voltage 54.4. My float voltage 54.4. My lithium battery pack manages the absorption timer. Equalization voltage not used. End amps, again, the BMS manages. And of course, the only time I would drop your battery capacities is if the inverters aren't communicating with the product. So if it's an Outback and you don't have communication, you set it to lithium and then you set it to 390 amp hours. If it's a Schneider and Magnum, 275 to 300 ballpark is where I would set it again. Be cautious with that. Make sure you take care of it. Again, if you have any questions on that, especially since the lithium product is new, do not hesitate to give us a call, talk to me or Jeff Miles, and be more than happy to help you out. All right, so why is it so important for absorption time settings? This probably slide should have been a little bit before, but I like to talk about it here just to get everybody fired up. On the solar controllers, the absorption time settings, and actually really any charger, the absorption time setting is the most important setting. If it's not set correctly, you're going to have problems with batteries. We have a distributor in Africa who was buying batteries from another company. Actually, this was when I was in my Outback days. They put in a bunch of Outback FP1s, slapped them on the wall, hooked them to a couple of deck of batteries, left everything at default, and then a year later, all the batteries, 3 containers of batteries were dead. Is that a Deca problem? No. If it's a Rolls battery, is it a Rolls problem? No. What happened there is the installer did not properly design, did not properly set up the settings, and what happened was those batteries over a year period sulfated and they eventually died. There's absolutely nothing you can do about it. When you start your absorption time, you are only about 80% state of charge. Okay, so that absorption time, that 0.42 or the 0.38 is not the 50% depth of discharge. Those numbers are assuming that you're going to lose up to 40 to 50 to 60% of your total power or your total current going into your batteries during the absorption stage. And so a lot of people will call up and say, well, I'm only going to do a 25% depth of discharge so I can go a shorter absorption time. The answer is no, because the shorter absorption time is if you're only going to 90% state of charge. You could approximately half your absorption time. But if you're going below 80% state of charge, what's going to happen is as you take it down to 75, that first 5%, your bulk's going to be maybe half hour to an hour, and then you're going to be followed by your absorption time. And so again, that 0.42 and that 0.38 is not the 50% depth of discharge. It's the assumption you're going to lose 60% up to 60% of your total charge current, total I. Okay, total current. All right. So it's very important. On wind and hydro, there's typically no delay for the absorption time settings because you're using a dump load or a diversion load. And so what's happening there is when you have sun or when you have wind or you've got water flow, what's happening is that the diversion controller is dumping excess voltage out of the battery to a load. And so basically it's in effect a 2-stage charger. Something to keep in mind, a lot of customers complain about is Well, I've got my absorption time setting set to where your formula is, but my water usage is higher, especially for a flooded lead acid battery. Water usage is higher. Yes, that is the case. Water usage can be higher. And one of the comments that I always kind of make, and I don't know if it's good or bad, but water is cheaper than lead. And so if you're not absorbing your batteries correctly, you're not getting them to a full 100% charge, you're going to have to replace those batteries more often because they're always in a state of discharge. And so it's cheaper to replace water than it is to replace batteries. And so if you have a problem with that, definitely go out and put in a gravity-fed fluoride system, or even a pump-fed fluoride system, a hand pump. I would try to avoid the automatic pressurization, because if you get bad pressure on the lines, or if the pressurization pump fails, it's also using electricity. There's a whole host of things that can go wrong. Unfortunately, the best method, I think, is the gravity-fed systems. As long as someone's checking that main container, because gravity is unbeaten. Gravity, to my knowledge, has worked since the day of creation. So I don't think there's ever going to be a problem with gravity. Bulk absorption voltages for valve regulated product. AGM's 2.45 volts per cell, and this is at 25C. And gels is 2.38 volts per cell at 25 degrees Celsius. Okay, you need to have enough solar to get to a reasonable state of charge. Typically 10 to 20% of that, I like to shoot for the middle. 15% is where you're going to get under 3 hours for your absorption time. If you're not getting under those 3 hours, then what's happening is a good portion of the year, if you're 4 and 5 hours, probably 7 to 8 months of the year, you're not getting to a full 100% state of charge. And so be careful with that, and make sure you advise your customers that they've got to run their generators to get those batteries charged, and you have to run the generators for the full charge time to get them charged. Many customers will run the generator for 1 or 2 hours, the battery voltage will look good, and then they'll shut the generators off. But what happens there is that you start losing. If you get up, battery voltage looks good, you get into the, say, 85 percentile charge rate, then what ends up happening is you end up sulfating that top 15% of the plate. And when you're sulfating that top 15% of the plate, that will eventually spread into the rest of the plate and kill the batteries. So all lead-based batteries have to get a full 100% charge periodically. Generally, for a full-time off-grid house, that's at least once a week, preferably 2 or 3 times a week. For a grid-connected backup system, that's generally about once every 2 to 3 weeks at the most. All right, so here's some more settings. Basically, on our charge controllers, float voltage, typically 2.28 to 2.3 volts per cell. Inverter chargers, a little bit lower. I have this a little higher because when you have a smaller array, you're going to want to use that smaller, you're going to want to offset that smaller array and keep that in a higher float stage as much as possible. Equalization voltage on all these batteries, I like to see it disabled. Equalization time, disabled. End amps, 0 to 1.5% of the C20 rate if there's at least a 60-minute timer. This is in both cases. If there's not a 60-minute timer, you're going to need to drop your battery capacity to 70 to 80% of the C20 rate in order to get an accurate absorber end amps shutdown. Another thing to talk about real quick is battery temperature compensation. It is an absolute must for AGM flooded lead acid and gel batteries. I see, I go to a few sites a year, probably a couple dozen, 2-3 dozen sites a year. And I think I have seen the battery temp sensors on 2 sites this year, probably 30 or 40 sites visited that were actually properly affixed to the batteries. Battery temp sensors should not be on the top of the battery. Battery temp sensors should be mounted on the side of the battery in the warmest location of the battery bank. If you don't know where the warmest location of the battery bank is, get yourself a triggered infrared detector and figure out and detect and look at what the actual temperatures are while you're using them. It's a very useful tool, especially when you're troubleshooting gassing of batteries and when you're troubleshooting connections. It's nice to have that. Some of the products like the Midnight controller, like the Schneider inverters, the Schneider charge controllers, you don't actually enter in the 5, the 4, or the 3 millivolts. You enter in the number, the 0.96 or the 0.120. And this is pretty simple. For AGM batteries, that's 4 millivolts multiplied by the cells. So it's 48 volts, there's 24 cells. That's 0.004 multiplied by 24. That equals 0.096 plus and minus. Okay, and so what that means is that for every degree Celsius above 25, it's going to subtract 0.96. For every degree C above 25 degrees C, it's going to add 0.96. Okay, so if your batteries are 45 degrees Celsius and they're in a hot room, you should be battery temp comping at least 0.96 of a volt away down your charge voltage. And if you're not doing that, you're overcharging those batteries and you're going to kill them. And so it's important you're able to do this. It's simple. Again, 4 millivolts, which is expressed 0.004 multiplied by 24, that's 0.96. If we look at the gel, that's 3 millivolts multiplied by 24, that equals 0.072, and that's 0.003 multiplied by 24 equals 0.072. Okay, and so it's important that you do that, because if you have those products that are asking for that temperature compensation value instead of the 5, 4, and 3 millivolts, okay, you need to program that correctly. I can't tell you how many Schneider installs I've been to in the last 3 or 4 years that they've left it defaulted at 108 millivolts, and that's not correct for any one of these. That's not correct for any one of these. So you're not temperature compensating correct, which means you're overcharging or undercharging your battery, which means you're causing damage to your battery bank. And so try to avoid that. The battery temp sensor should not be attached to the post. Okay, I understand that Magnum and Schneider and few other companies make battery temp sensors that attach to the post of the battery. That is incorrect. We have visual evidence of a 15 to 20 degrees Celsius difference between the top of the battery and the side of the battery. And so there's a big air gap between the post, that post and the actual plates. And so you're actually trying to get plate temperature. And so if you have the side of the battery, so if we have a battery here, we got a label right here, we got a positive post and a negative post. I'm going to want that temp sensor somewhere right here. I do not want it on the post, I do not want it on the top, and I don't want it on the short side. So these 3 locations are a big no. Don't do it. And so basically you take a piece of double-sided sticky tape, you attach it to the side of the battery, and then I would take some duct tape or electrical tape, go around it a couple times to hold the temp sensor on there, and that should be good for you. Here are some other settings to talk about. Rebulk and refloat settings. Rebulk and refloat. This is primarily an outback setting. And so what it does is, if you have a grid source and it's connected to grid source, when it finishes charging, when it finishes the absorption stage, it goes into silent mode. When it finishes the silent mode, it then goes into, when the voltage goes below the rebulk or the refloat set point, it will rebulk or refloat the batteries. Okay, this is a specific outback setting. Battery manufacturers don't care about this setting. It's an outback specific setting. It's a setting that you can use to prevent the batteries. If you set your refloat, if you had grid all the time and you set your refloat or your rebulk, if you set your rebulk setting at say 52 volts, that would probably prevent you from going below 60–70% stated charge at any time. Okay, but that means you would have to be running your generator constantly, or you'd have to be plugged in the grid. For a true traditional 100% off-grid system, and if the array is under design where your absorption time is longer than 4.5 hours, you'll never ever use the rebulk or refloat set points. And so in most cases, most systems, rebulk and refloat and rebulk set points are a wasted setting. Next is low LBCO or LVD. Those are the two common names for it. Be careful with this setting, okay? And you want to be careful with this because on a 48 volt system, this setting becomes defaulted at 44 volts, okay? That is way too low. If you leave your LVCO or your low voltage disconnect at that low of a voltage on a 48 volt system, there's a good chance that you are going to damage your batteries. Okay, generally we advise 45.6 to 46.8 volts. Now this depends on your client. If you have a client that has a whole bunch of light loads, computers, monitors, you know, they're not running air conditioning, they're not running any kind of heavy motors, basically, you know, a server farm or, you know, a small business with a bunch of computers and lights, then I would probably set it at this close to this 46.8 volts to make sure that they're holding the batteries at a higher state of charge. The battery is going to last longer. Okay. If you have a client who's using a off-grid home and he's got a bunch of saws and he's got a workshop, I would go a little bit lower on that setting. And the reason for that is that when those saws come on, when that workshop, when the customer's in the workshop, those battery voltages are going to collapse for a period of time. And so you don't want it to go below 46.8 and shut off. And so you want a little bit of a buffer there. And so this is going to depend from customer to customer. There is not any one general setting that is correct. And so you've got to be cautious with that. And it's varies. So you can install 100 systems and you might get 50 or 60 different variables in that setting. Automatic generator start. Typically, automatic generator starts between 45.8 and 47.6 volts. A lot of people ask me, why below 48 volts? Well, because the batteries are typically under load, and depending on how much load is running, say if you're running at the C20 rate, typically you're going to want to start your generator between that 47.4 and 48, maybe even 48.4. It depends on how picky you are, how picky you or your client is about what kind of depth of discharge you're doing to your batteries. And so generally I'm going to set that at 45.8 to 47.6 volts. The next two settings are primarily for sunny islands. I run into this all the time. There's two timers. There's a boost voltage timer and a full timer. Okay, and so boost is the temporary, basically the everyday charge. And so what that means is when the sun comes up on Wednesday, it goes through a bulk absorption for the boost timer and then goes to float. The problem is that a lot of people set this. If you're like, for example, I had a customer send in information yesterday. His full timer should have been 7.5 hours of time. Okay. And then his boost time was set to 3 hours. And so what that meant is that the customer was only getting the batteries to about 85, maybe 88% state of charge on a daily basis. And then once every 14 days, they were doing a full charge at that 7.5 hours. Okay. While that might be okay, but what's going to happen is a year, 2 years down the road, that interval between that 7 and 14 days and how low they've been running the batteries normally is going to cause a state of charge reset problem where you load the sunny island down and the state of charge drops below 20% and it starts the generator to try to go through multiple charge cycles to fix that. So you want to try to avoid that. So if I'm setting boost and float boost timers, what I'm going to do is I'm going to make sure if this is 7.5 hours, I'm going to set this for about 6 to 7 hours, maybe 6 to 6.5. Okay, you might be able to get away 5.5 hours, but you want to be careful of it because you want to target that 90 to 95% state of charge. Because if you're not going to find that 90 to 95% state of charge, if you're not going to get to there, what that's going to do is that's going to start causing sulfation. and it's going to be very hard to break up. And so what I typically do with the Sunny Islands is I'll calculate my full timer, and then I'll take 90% of my full timer and enter that into my boost time. Battery charge factor and battery efficiency. There's a couple of different trimetric type meters out there that use this. Outback uses this. Basically what this is that this is for a flooded lead acid or a lead-based battery. I'm going to start with 80% to start. Most of them are defaulted at 94, 92, 95%. I don't know a lead-based battery that's greater than 80% state or greater than 80% efficient. Typically, if you take out 100 amp hours, you have to put back 120 amp hours. Okay, and then what I'll do is at year three, I'm going to minus 1% per year for every year after year 3. So year 5, this is going to be 79, 78, 77%. Okay, coming year 5. The nice thing is that if you're going to use a lithium battery, lithium batteries, you would set this to 97%. Okay. All right. So at this point, you're finished at this point, and then actually that's incorrect, because if you're not finished, every customer is different. Every customer is different, and so you can have different systems, different settings. So what you're going to want to do, if they're flooded batteries, you're going to want to recheck the specific gravities. If they're AGM batteries or gel batteries, I would have the customer do a load test. So you do a static load test where there's no load, check your voltages on every one of the cells, put the C10 discharge rate on for 2 to 4 hours, and then have the customer measure those voltages and report those voltages back to you. If you have weak batteries, those batteries will be collapsing much faster than the rest of the system. So remember, once you install an off-grid system with batteries, you're basically married to that customer. So it's a good idea to go back through and follow up. All right, so at this point, I'm going to check to see if we got any questions. I don't see any questions. We lost a couple people, it looks like. At this point, I want to thank everybody for coming. And if you have any questions, feel free to send me an email. I'll be more than happy to try to help you out. Thank you.